Pythagorean. Pythagorean theorem. All right. It says, you've worked with it before, I'm guessing. Well, we're going to work with it in so many ways, you're going to be kind of sick of it. All right. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So let's just draw a little picture so you know the names of all of these. Hypotenuse is where? It's always opposite the right angle and the longest side. Hypotenuse, opposite the right angle, and then what are these two called? Legs. And they can be, you know, flip-flopped, it doesn't matter. Each of those are legs. What is the Pythagorean theorem? Correct. And A and B is always the what? The legs, and C is always the hypotenuse. Just to review. Okay? All right. Identify the unknown side as a leg or a hypotenuse, then find the unknown side length of the right triangle. Write your answer in simplest radical form. Okay, so what are we looking for here? Leg or hypotenuse? Hypotenuse. And we know that the hypotenuse in the Pythagorean theorem is always C. It doesn't matter if you make this A and this B or vice versa. It makes no difference. So I always write this down. You don't always have to, but it's kind of helpful. I'm going to make this A and this B. Doesn't really matter. Equals C squared. You can jump right to your calculator. Did you know that? And just add these like this. Or you can write them out if it helps. And when you add these together, you get 225. Do you have to write this all out when you're doing these homework problems? Not necessarily. I want to see a little bit of work, but... And then, how do I get C? Correct. You undo squaring by square rooting. So C equals 15. No simplifying necessary there. Okay? All right, are we looking for the legs or the hypotenuse here? Leg. So it doesn't matter what you assign what, but where's the hypotenuse? Which number? 50. Correct, because it's opposite the right angle. So this is my C. Let's just make that A and that B. It doesn't really matter. So I'm going to write A squared plus B squared equals C squared and plug in what I know. I know A squared is 30, or A is 30, so I'm going to write that. Plus B squared equals 50 squared. Now this is what I was talking about. You can spend time multiplying them out, but if you go to your calculator, you know you have to get B squared by itself, right? So sometimes I just like to say to myself, okay, I got to subtract 30 squared from both sides, so I can just do that right on the calculator. It looks like this. See what I'm saying? It's just a little shortcut. You don't have to. And then if you push enter, it's 1600. See it? It's easier. So I subtracted 30 squared from both sides. B squared equals 1600. See what I'm saying? Makes it a little easier. As long as you got calculators, you might as well. Don't say it's 20 squared, though. That's a nini, nani, no, no. It's not 20 squared. Okay? So then you take the square root. What's the square root of 1600? Correct. Okay? All right, turn it over. No problem. That's easy stuff. All right. Randy made a ramp for his dog to get into his truck. So I was starting to draw a picture, look. And then I gave up. Tried to try a truck. I'm like, no, we're not going to do that. We're just going to draw a ramp to get the dog into his truck. The ramp is 6 feet long. And the bed of the truck is 3 feet. Here's the bed of the truck. Is 3 feet above the ground. So I'm just going to say that. Okay? Approximately how far from the back of the truck does the ramp touch the ground? It should be touching. You should do that. So I'm looking for what? And I'm looking for a leg. We have to make a big assumption here. What's this big assumption that we have to make with this problem? We have to make this assumption that it's a right triangle. I don't like that much, but we'll assume that it is. So we're looking for a leg. I don't care what you assign A or B to. It doesn't matter. Know that the hypotenuse is always C. So A squared plus 3 squared equals 6 squared. And then you can take 36 minus 9, if you can do that in your head. You can just do it on the calculator too. And A squared equals 25. Oh, thank you. 27. I can't do that in my head, apparently. Okay. Now, we're not going to use decimals. So we have to take the square root of this, which isn't too bad. We can do that. Does 27 have a factor that's a perfect square? Yeah, so I'm going to write it as the square root of 9 times the square root of 3. And A will equal 3 times the square root of 3. Remember that? This is all coming, I believe, later in the chapter, special right triangles. You need to be pretty good at doing this. It'll tell you whether it's a 30, 60, 90 or 45, 45, 90, that kind of stuff. All right. So find the area of the isosceles triangle with side lengths 20, 20, and 24. So I'm just going to draw a picture. 20, 20, 24. If I'm finding the area, I need to know how to find the area of a triangle. What's the formula for area of a triangle? Correct. Area, I'm going to write that down, equals 1/2 base times height. Do I know the height yet? Nope. I do not know the height. I need this. Right? Oh, guess what? That kind of brings into play the warm-up problem. All right, so we need to know x. We could set up a proportion. We could set up a proportion to find x, or, and then this would be 24 minus x. Boy, I cannot write 24 minus x. And you could do a proportion. Or by AAS and CPCTC, whatever, we know that x is going to equal what? 12. So I'm not going to go through all that work, but you could set up a proportion or just kind of justify it that way. And then we're going to look at just one of these triangles. So I'm going to take one of these triangles out and just kind of write it like this. You don't have to necessarily do that, but I know that's 20 and I know that's 12, right? In order to find the height, I have to use what? I got to see, I took this piece right here and just redrew it. I know that's 20, that's 12, and I got to find that to find the height of the triangle. So I use the Pythagorean theorem. I will say 12 squared plus b squared equals 20 squared. And then you can just do 20 squared minus 12 squared on your calculator. What do you get when you do that? Do it. See if you know how. What'd you get? I got 256. Is that what you got? Yeah. Okay. Then you take the square root of 256, and what do you get? 16. All right, so now I have the height of my triangle, which is 16. Can I use this now to find the area? No problem. All right, the area is equal to 1/2 times 24 times 16. So 12 times 16 on your calculator. 192 inches squared, because you would not want to leave the area naked. Don't forget the units. Cool? These are some common Pythagorean triples that are very helpful if you can remember them. This one especially, this one I sometimes remember, these I don't always remember, but these two are very helpful to remember. They're just common triples. You would find out, let's say you were given 3 and 4, you would find out that that's 5. And you use them sometimes. Okay, same with this one. If this was 5 and 12, this one is 13. These are just common Pythagorean triples. Do you have to memorize them? Not necessarily. It's good maybe to know those two. They will help lessen your workload later. But that's that. All right? So let's get started. Okay, here you go. This is how you do it. This means 5 times the square root of 3 times 5 times the square root of 3. I just reordered it. Maybe you don't have to, but it's all multiply, so you can. And that way you can see 5 times 5 is 25. Square root of 3 times square root of 3 is just what? 3. 25 times 3 is 75. We had to review that because you'll be using that later. So, Emma, you good? Yes, you could distribute the 2 as well. Yes. All right. Shh. Let's look at this. We don't need to use a ruler. We're just going to kind of draw a right, an acute, and an obtuse triangle labeled triangle ABC. And angle C is the largest angle in each triangle. So let's start with the right. What's the largest angle in a right triangle? Right. So it's going to be something like this, right? And where is C going to be? Here. And then I'll just make that one A and that one B. An acute triangle is a little trickier, but you know they all have to be less than 90, so I made this one pretty close to 90 but less than. It's hard to tell exactly, but we're just going to assume that's the biggest one.
Wouldn't that be more than 90?
No, this. No, I kind of tried to just do it. I mean, maybe this one's the biggest one. Maybe that is. I don't know. It doesn't really matter. You get the idea.
Yeah.
And then obtuse is easy. Just kind of draw an obtuse triangle. C is the biggest one. A and B. I don't even know why that's there, to be honest with you, but it's got to have some relevance somewhere. So anyway. All right, these theorems are in the book. This is what you're going to basically be working with today. And when I was looking this, I'm like, why do they have it labeled AB, AC, and CB? I don't know. I guess here, if you look at this as AB, it's also the hypotenuse, isn't it? So if you think of it as C squared equals A squared plus B squared. They're just using the side lengths to name it. If this equals is true, then it's a right triangle. If these two squared added together equals the hypotenuse squared, then it is a right triangle. Okay? Then it says, all right, well, what if C squared ends up being less than A squared plus B squared? So this is the important part right here. Then it's going to be an acute triangle. Then look at this picture. Here's the relevance, I guess. It says if AB squared, the longest side here, is greater than those two squared added together, then it's going to be a what? An obtuse. So you could look at it as C squared, But I guess the reason they use these is because they're not necessarily right triangles, so they don't want you to confuse it with the Pythagorean theorem. But just consider this. Okay, then it's an obtuse triangle. You'll see what we mean when we practice this a little bit. All right, turn the page. Let's do a little bit of stuff with this. Or turn it over. So, classify means to name it. Classify the triangle with the given sides as right, acute, or obtuse. Well, we always have to identify the longest side. Okay, that's what we're going to check here. We're going to check here if the other two sides are equal, greater than, or less than. And then we can identify what it is. So the longest side, I'm going to say this is C. I know that that's going to be by itself on one side here. So I'm going to say, okay, is A squared, 8 squared, equal to, I'm checking that. Check and see what happens here. 4 squared plus 4 times the square root of 3 squared. I'm going to see what happens. If it's equal, less than, greater than. 64 equals 16 plus 4 times 4 is what? Square root of 3 times square root of 3 is what? 16 times 3. Anybody know? 48. I'm still checking to see what's going to happen here. So 64 equals 64. So what kind of triangle is it? It is a right triangle because it makes the Pythagorean theorem true here. Okay? All right, let's do another one then. The longest side is what?
14.
So I'm going to just say that's my C, however you want to look at it. And I'm not even going to put an equals in between there because I'm going to find out what's going to happen. And then I'm going to check 10 squared plus 11 squared. I'm checking for this right here. Let's see what happens. 14 squared is 196. This is 100 plus 121. 196. And then this is 221. So this side with the other two sides is greater than the longest side here. So it's going to be what? Obtuse. Oh, excuse me. Let's check. These two added together are greater than that side, right? So it's acute. What do you think is going to happen at the end? This one here. Yeah. Now, you may not know what's the longest side. How could you check? Yeah, just take the square root of 61. It's 7.8. Just know that's going to be what you're checking for. I always put an equals there. It doesn't really matter. It's just habit for me. I'm just checking that just to see what's going to happen. 61 equals 25 plus 36. Oh, 61 equals 61. We're right. It is a right triangle. We didn't do an obtuse here. But you will get an obtuse in your homework. All right. Here's another thing you got to do. Can the segments with lengths of 11.2, 6.5, and 7.1 form a triangle? Well, you have to decide that by using the triangle inequality. You have to try it all three ways here. So, I'm going to say this is part A and this is part B just to help with setup. Part A, we're going to check all three ways. We're going to say, okay, I'm going to use 11.2 and 6.5 squared plus 6.5 squared. Let's see if it's greater than 7.1 squared. Let's see if that's true. Let's just check. So I didn't even do this. 11.2 squared plus 6.5. You can just do it all on your calculator. Squared, enter 167.69 is greater than, is that going to be greater than 7.1 squared?
Why would we do like 11.2 as the biggest?
Oh, you could check it that way. Yeah, that's true. Yeah, we should.
So how, okay.
Yeah, because it's
Yeah.
Because that's the biggest side. You're right. Let's do that.
Is that like
6 point, yeah, I think that's true because you'll find out whether it's right, acute, or obtuse. Yeah, never mind what I just said. 11.2 squared. Let's check that. What happens? So 6.5 squared plus 7.1 squared is equal to 92.66. And then 11.2 squared is 125.44. So these two added together are greater than. So what kind of triangle is it going to be?
2?
So this is a yes. No, take a look. The two sides added together are greater than the C. So it's acute. Oh, it's not. It's less than. See, I've got my notes all wrong. Sorry. It's obtuse. Holy cow. I'm thinking there's something that we're not doing right here. Let's see.